Hi everyone, welcome to the Loopile. Today in this video, we'll be solving June Leetcode challenge, and the question for today is and queens 2. It is pretty much similar to the previous question, that is the and queens that we have solved. I would highly recommend you to just watch the previous video that I had uploaded on and queens. The solution for this question is similar to the previous one, and there is just a little bit of modification in the code. So let me just read out what the question states. The question states that an and queen puzzle is the problem of placing and queens on an and cross and chessboard such that no two queens attack each other. Given an integer n, return the number of distinct solution to the and queens puzzle. So we'll be given an integer n, and that will be the size of the board. That is, if we are given n equal to 4, that is a chessboard of 4 cross 4 size. So we'll just have to return the possibilities of the placement of queens in such a way that they won't attack each other. So when n is 4, these are the two possibilities or the two possible arrangements that can be made such that no queen are attacking each other. So in that case, our output is 2. Similarly, when we have only one block, that is one queen, that is only one possibility to be made. Now let me just dive you through the solution, what our approach would be. So like previously we did, that is whenever we placed a queen over a certain position, we used to just block the columns for that, and we maintained diagonal sets also, so that we could just add the summation of row indice and column indice, and that such that if at a particular position another queen is being placed and that sum of row indice and column indice is not already present in the set, then that place is safe for the next queen to be placed at. So this way we used to just get or arrive to a solution that is better for all the queens that are on the chessboard, unattacked by any other queen. So again, let me just continue what we did in the previous solution. So as I said, if we are at this position, we would be maintaining the column array, and we'll check if this is the safest position of the next queen. So since the row indice and column indice of this position is same of this position, so we won't be putting our next queen over here. So we'll just place our queen here. And next, again, we have this column blocked. So like this column is already present in the set. So we won't be, for the third queen, we won't be visiting this column. And since the sum of row indice and column indice is same as this one, or the difference is same as this one, so we won't be placing it over here. And since this column is also added because of this second queen in the column set, we won't be putting our queen over here. And the summation of this row indice and column indice over this position is also in the set, so we won't be putting our queen over here. So since these all columns couldn't fit the safest place for the third queen, so we'll ask the second queen to move to the next column and check the possibilities of the same. So again, we have this column already present in the set. This column though is not present in the set, so we'll just add our queen over here or place our queen over here. And yeah, and just we'll switch to the next queen and find the safest place for the fourth queen. So the fourth queen would check whether this position is safe. This is not, because this particular column index already lies in the column set, and also this also lies already in the column set. For this, the diagonal of this third queen would be would append the summation of the row indice and column indice. Thus this is also not safe for the fourth queen, and this again is the column already added because of the second queen. So again, this is not a safest position, so we'll roll back and say this was not the correct position. So this third queen would backtrack, and the second queen, since it was at the last position, has no further columns to be placed at, so it will roll back the first queen, and the first queen will just move to the next column. So this is where it will start. And again, for this queen, the same process starts repeating. This column would be appended in the column set, and the summation of row indice and the column indice in the positive side, and the difference of row indice and column indice in the negative set would be added, and the next queen would be called to be placed in the next row, and each column would be checked whether the summation of row and column is already present in the positive diagonal set, or the column is it present in the column set, or the difference of the row indice and column indice is present in the set. If it is present, we won't do anything. We'll just change the column or increase the column number. And if it is not, we'll just place our queen to that position. So for this position, this will be the positive diagonal for the this queen. So summation of row and column would be same as this one, and for this the column is already added or the column is already visited, thus this position is blocked and we cannot put our next queen in this position. And next we have this, so the difference of row indice and column indice over here is already being added in the set because of our first queen, so we won't be placing our second queen over here. So only this position left, which is safest so far, so we'll place our second queen over here. Next we'll again start checking at each position, so we'll find that this is a position which whose column, whose row in summation and columns summation is not in it, and difference of row indice column indice is also not in the set, thus we'll just add or place our third queen over here. Next we'll check for the fourth queen, which position is the safest, and we'll come to the conclusion that this one is the safest so far. So this is one of the configuration or the arrangement of the queens in a 4x4 chessboard. So once this is done, we'll start checking for the next column. So it will start with the next column and check which is the safest position. Since this comes to be the safest position so far, so we'll place our second queen over here. Now next we'll just visit all these and we'll find that this one over here is the safest position for the third queen, and like the last queen, we'll have to check it again and we'll find that this is the safest position for the fourth queen so far. Now this is the second arrangement that is possible for the four queens on a 4x4 board, so our output should be 2. Now let us simply deep dive into the code, and we will be declaring the three sets, that is the column set, the sum diagonal set, and the difference diagonal set, which will be having the summation of row indice and column indice, as well as the difference of some row indice and column indice appended in it. So these three are sets. Next we'll be having the count variable. So in order to reduce the complexity of calling the variable local variable or the reference to it, we'll just take it as an array element and we'll do certain manipulation, that is we'll be just incrementing it by 1 every time, so that 0th index of the count array would be getting changed each time we encounter a possible permutation or combination of the arrangement of the queens. So we'll start declaring our function. So we have this def solve, which will be taking starting row as the parameter. Then our base condition would be whenever our row number reaches the last position, so we'll just return, but before that we'll just have to increase the um, count variable, so we'll just increment it by 1. Next we'll start traversing each column. So for C in range of n, we'll check whether that particular position is safe for the next queen to be placed. If it is, then we'll just do certain other things, but if it is not, we'll just simply skip those things. So if C is already in column, or the summation of row indice and column indice is already there in the sum diagonal, or the difference of row indice and column indice is already there in difference diagonal, we'll just skip all these things. So we'll just write continue. Now next what we'll do, we'll just start adding C in the column set, and summation of row indice and column indice in the sum diagonal set, and we'll add the difference of row indice and column indice in the difference diagonal set. Once this is done, we'll just have to call our function again for the next row. So we'll call r plus 1, and this is done. Now since we have checked for one possibility, we'll just have to do some cleanup. So we'll again just simply copy this and start removing whatever we have added over here. So we'll do removal of the column, removal of the summation of row indices and column indices, as well as the removal of difference of row indices and column indices. So this should do the work. We'll just call it for zero index and we'll simply return count of zero because it was an array and we were just making changes over the first index of the array. So let us see if there is no error. And yes, so this is our solution, and congratulations, I guess. Yeah. So this is our fifth day streak, and we have completed today's Leetcode challenge. If you wish to see more content like this, or if you found this video helpful, please make sure to like this video, subscribe to the channel, and make sure you share with your friends. And I hope to see you in the next video. Until then, stay tuned. Thank you. Bye bye.